look at problem number 2. The problem is shown over here. There is a truss, as you can see here, there are 3 restraints, 2 here and 1 here. If you look at this particular truss, this is a triangle attached to another triangle, attached to another triangle and attached to another triangle. Every triangle is rigid, we have already seen that in the previous cases, which means when I attach each triangle like this entire body is like a rigid body, and there are 3 external constraints, which means it is a body for which we can solve for the reactions and it is possible to find out the member forces. Okay. Problem number 1 deals with all the number of equations that we will get, etc., etc. We will not venture into that, we just have to find out whether it is determinate and solvable. I mean we see that it is solvable. Now we have to use method of joins and find out member forces. Okay. Now how do we go about doing this? What is method of joins? I have all these joins. Method of joins basically tells me that take each joint, take up the free body of the joint and use those free bodies in order to solve for the member forces. Okay. For example, if I have to write down the member force for this, I usually use just AB equal to say 2 newtons. Okay. I am going to use something like this. This AB means force in AB. Okay. Okay. Where do I start? Okay. In general, I will start finding out the reactions, but in some problems it is not necessary to start with the reactions. This is one such problems where I do not have to start from calculating the reactions. The first thing that I will look up is I will observe each of these joints. If you look at this joint 1, 2, there are 3 members over here. Every joint it is possible for me to find out 2 equations, the horizontal equilibrium and vertical equilibrium of each joint. Okay. There are 3 members here, which means 3 unknown forces exist at this particular point. If I look at this, there is a known force and 2 unknown forces. Here 4 unknown forces. If you look at this, including the reaction, there are 4 unknown forces, including the reaction here there are 3 unknown forces and so on. As you can see, the best point that I can start off with is point D. Why? Because there are only 2 unknowns and I can easily use those equations in the horizontal and vertical equilibrium in order to solve for forces in these 2 members. Okay. So that is how we start off with. So we write joint D. First thing that we have to do is to draw the free body. How do I draw the free body? I cut here and I cut here, remove this. Okay. So that is what I am drawing here. This is point D, joint D, I have cut here. Naturally, having cut this, since this is a truss member, I know there will be a force like this. Mind you that I am using a particular direction over here. We will always take the direction to be away from the joint. Okay. In this particular case, if I cut like this, the force direction is taken to be away from this. If I take it like this, it means that the member force is in tension. Okay. And then let us write down, this is the force CD. Some of us may write it as DC. We will use a particular order here, we will go for alphabetical order. So we will write it as CD. So even if I cut this way and take this, I will write it as CD. Okay. How about this? This is DE. There is a force acting here. This is very simple to see that if I take for example this is x direction, let us say this is y direction, sigma Fy I am going to take up first. The reason is there is no other force in the vertical direction except this dE, right, which means dE equals 0. I will go here and write it as 0. It is easy when I start to use other joints. Now let us look at this CD, and that can come out from sigma Fx equals 0. Mind you, I always do this direction is positive is what I use. Here I have minus 75 kilonewton minus CD equals 0, which means CD equals minus 75 kilonewton, right. How do I mark it over here? This is a direction that is in the opposite direction because this value is negative, and I will use 75 kilonewtons here. Now it is clear because if I take this point, I know what is already known. Okay, is this clear? Naturally, since there is a negative value here, this member is in compression. That is obvious because there is a force acting in this direction and the member force has to be able to take it. Okay. So, we have finished joint D, and thus we are able to find out two member forces. Now we will look at this again and ask the question, which is the other joint that we can take up. Okay. Naturally, you can see this particular joint which has 3 unknowns, which had 3 unknowns earlier, now has only 2 unknowns because this member force CD has already been found out.